Hi, welcome to the review video for the SDS5034X Scope. Before we get to the actual review of the scope, I want to discuss Siglent's website. When you purchase a scope, don't purchase the scopes or any Siglent equipment from Amazon. Purchase it right from the Siglent website. And the reason for that is the Siglent scopes have lots of features. Like down here, you can get all these features. And if you buy them through this, you get those features with the scope. There's no mechanism on Amazon for purchasing the features along with the scope. So it's better to do it from the Siglent website. So let me go back to the Siglent main page here. And we're going to go to the digital oscilloscopes. Sorry, my website is, my internet is so freaking slow. Oh my God, it's horrible. It takes me hours to upload videos to the internet. Literally 6 hours to upload a 20-minute video. It's ridiculous. So what happened in the past, for those who followed the earlier video, I purchased a Regal scope, a Regal 5000 series scope to be my top bench scope because I got a really good deal on it. And I purchased a Siglent SDS5034X to be a small backup, inexpensive backup scope. And it turned out, if you watch that review video, that this backup Siglent scope actually performed better than the Regal. And so now what I want to do then is I redirected money from my home improvement project because I'm going to buy a top-of-the-line Siglent to be the main scope. Video, I explained what the meaning between the bandwidth and the sampling rate is. Now for Siglent, this 5 gigasamples per second is kind of a misnomer. Okay, what it means is that when you have, let's say, a 4-channel scope, okay, channels 1 and 2 and channels 3 and 4 are pairs. And in each one of those pairs, if you only have one channel on, that channel will sample at 5 gigasamples per second. If you have both channels on in the pair, then each channel only samples at 2.5 gigasamples per second. So 2.5 gigasamples per second is fine for my purposes because I'm replacing my Tektronix scope, and that scope samples all 4 channels at 2.5 gigasamples per second. The benefit of this, it allows me to go to 5 gigasamples per second if I need to by using 2 of the 4 channels. Okay, and so then if you've got 2.5 gigasamples per second is going to be all 4 channels on, well, usually for a 10 times oversampling, then you want an input bandwidth of at least 250 megahertz. Okay, so that's why I chose the 350 megahertz. That's why I chose the SDS5034, because that's got the right bandwidth that matches the decent sampling rate. Okay, and if you look, if you just, the only difference between this scope and this scope is just the input bandwidth. And so just to go from 350 megahertz to 500 megahertz, it's almost doubling the price. And then to go to 1 gigahertz input, it's like $7,000. I'm like, why? Why are you going to have a 1 gigahertz input when you can only get at tops 5 gigasamples per second out of 2 traces? Okay, that's barely 5 times oversampling. So I don't know why anybody would want that. I mean, if you're going to pay the money for a 1 gigahertz input bandwidth, you're going to want at least 10 gigasamples per second. So this is more than enough for my purposes, and so we're going to go. That's why I chose the 5034X. Okay, now when you go to the 5034X, the base price is $3,600. Okay, and then you get all these options you can select. Now, I looked at this, and it's nice to have a little function generator with the scope, but the thing is, just the license to turn it on is $300, and the little device that plugs into the scope uses one of the USB ports. That's $160. And I'm like, okay, so that's like $450. And I'm like, why would you want to do that when you could just go purchase one of these arbitrary function generators for $50 more, that's got 2 channels and does 40 megahertz. Okay, so, and it's got, 1.2 gigasamples per second. So this thing is a much better buy. If I'm going to spend $450, I'll just pay the extra $50. But I actually purchased the top line model to get 120 megahertz output frequency. So I already have one of these. I haven't reviewed it yet. And so it doesn't really pay me to spend $450 for a 25 megahertz arbitrary waveform generator. Okay, so I skipped this feature. Definitely want the MSO function. This is basically a logic analyzer. Very useful in today's world. Now for serial decode bus support, well, I'm more interested in these guys here. And now they say that CAN and LIN are included as a standard feature. And why is CAN? Is this the same thing? I don't know. FlexRay I might get into in the future. Maybe I'll be getting into CAN, but I mean, it looks like there's one there. So I don't know. I figured that if I ever do get into these, I'll either just use the scope raw and do the interpolation manually, or I'll purchase the license later. Because the scopes come with all this stuff. It's just what it gets turned on. Okay, so I didn't ask for any of these. Don't really care for the power analysis because I can pretty much do that myself, and I don't do much power analysis. Okay, so these are the only features, and that's what I paid. I paid $4,400 for the scope. When I got the scope, my friends, it had everything turned on. So I got $7,000 worth of stuff for $4,500. I don't know if they knew that I was going to be reviewing the scope and they turned everything on as a courtesy. I don't know why, but everything was turned on. And it wasn't temporary license, because a lot of this stuff, they give you temporary licenses that expire over so many hours of operation. These were all listed as permanent, forever. So that's what I got. Let's go to the review. If you recall from part 1, the Regal scope, which I had purchased to become my flagship scope to replace my Tektronix, didn't perform as I had hoped. And so what I did is I canceled the replacement of my roof to redirect funds by other things, but also to then purchase the upper end Siglent scope, because the smaller Siglent scope that we had before worked very good, but it was a lower end scope. Okay, so now we have a scope now that actually compares 1-to-1 with the Tektronix. Because the Tektronix here, okay, it is a 300 megahertz, 2.5 gigasamples per second scope. And I explained in the other videos what these numbers mean, so if you need to go back to refresh yourself, go back to that video. Okay, that means on a per channel, it's got 4 channels here, it can sample 2.5 gigasamples per second each channel. Okay, the Regal plays a little bit with the numbers here. This Regal says 350 megahertz, 8 gigasamples per second. Okay, what that really means, that doesn't mean 8 gigasamples per second per channel. Okay, they play games with their numbers here. If you only have one channel on, that channel can do 8 gigasamples per second. But if you want all 4 channels running simultaneously, it's only 2 gigasamples per second. So this is a little bit less than the Tektronix, but that wasn't a really big showstopper back then. What was a big showstopper is this big Noise-a-Palooza signal we had here. Very unacceptable level of noise on this scope. And so I got in the higher end Siglent here, and that's 350 megasamples per second at 5 gigasamples per second. Now, what their number means is if I have only 2 channels on, the channels work in groups. Okay, channel 1 and 2 works as a group, and channel 3 and 4 work as a group. If you only have 1 channel on in each group, that channel can sample at 5 gigasamples per second. Okay, if you have all 4 channels on, that's 2.5 gigasamples per second per channel, which is the match for the Tektronix. Okay, now the other thing that I had the last time you were here, we had a little bit of input offset on the Tektronix. and a little bit of, you know, input offset. And it dawned on me, I'd forgotten to do the input calibration on the scopes, which clears the input offsets. And now I've run it on the Tektronix, and Tektronix takes a while to run it, but you have to take all the scope probes off. And you can see that our peak-to-peak noise, okay, we just have channel 1 open, is 480 or less than 500 microvolts is the peak-to-peak noise. The mean is minus about 50 microvolts, which is good. It's a decent offset. And the RMS is like under 80. Okay, I tried to run. You can see I've got that thing open for the self-cal, and I hit the start button. After I hit the start button, there was no indicator that anything was doing nothing. I didn't get any kind of progress bar, no flashing light, no little dialog button that says please wait. And this scope is completely inoperative. None of the buttons work anymore. Okay, I can't even turn off the run stop up here. It doesn't work. It just froze. It hung. Okay, so again, this scope is, you know, maybe that's just a software upgrade. I have the latest software updates on this scope. So, I mean, that's something Regal's going to have to fix in their next software update. That's pretty sad that would happen. Okay, so this scope is inoperative right now. Okay, the Siglent ran beautifully. It did its input offset, and I'm going to focus in on its values now. Okay, and it's matching the Tektronix as far as values go. Okay, 400, less than 500 microvolts peak-to-peak noise. The mean is minus 23 microvolts, which is very good. And the RMS is actually less than the Tektronix. Okay, so that's working good. Now right now we're running, all the scopes now are running with 20 megahertz bandwidth, DC coupling, 1 mega ohm impedance, 5 milliseconds per division, or for the Tektronix can't do 5, so we got the Tektronix on 4. Okay, so now here a funny thing happens when you plug in a scope probe on the Siglent. And I'm going to plug in a scope probe on the Siglent. Remember those spikes we had last time? They're kind of hard to see, but they are there. We had those on the smaller Siglent scope as well. And you can see that our millivolts are like upwards of 10 millivolts peak-to-peak noise. And I'm like, what the hell's going on here? So I plugged in the scope probe on the Tektronix. And I'm going to do that now. Let me get out of the chair. Oh, and the scope probes are just shorted. Okay, and that's good. This guy goes to 4 millivolts, which is fine because it actually changed from a ×1 to a ×10 probe, so that increase in noise is acceptable. So it doesn't really look any different. It looks fine. 4.6, less than 5 millivolts peak-to-peak noise. The input offsets, you know, under 200, or under 500 microvolts. Oops. And the RMS is, you know, under 900 microvolts. So, I mean, that's kind of expected when you go from a ×1 probe input to a ×10 probe input. So what the heck is going on here? I started playing around. I plugged in a Tektronix scope, Tektronix probe into the Siglent, and it worked fine. It gave me the same answers we got on the Tektronix. Okay, so what I'm learning here from this is that the probes for the Siglent aren't very well shielded. Okay, we can buy different probes that are better shielded. You could even buy Tektronix probes, because when you plug the Tektronix probe in, the Regal identifies them and actually changes to ×10. Let me show you that now. You can see here, it knows it's a ×10 probe. When I take the Regal probe, the Siglent probe out, you see it drops back to ×1. Okay, then when I plug in a Tektronix probe, it identifies it as ×10. Okay, so the Siglent can interoperate and work with the Tektronix probes, which is nice. Okay, and you can notice we have none of the noise, and all of our values here, down at the bottom are the same values we get from the Tektronix scope. Probably even a little better. Okay, I hope you can read those in there. But that's about the same signal we're getting for the Tektronix. So the Siglent probes are a little bit poorly shielded. The scope is good, it's just the probes. And I would probably not have a problem going and purchasing Tektronix probes to use on the Siglent to get this performance. And I think that's what I'm going to do. The Siglent has a feature that both the Regal and the Tektronix don't have. They have the ability, acquire, menu, acquisition. We want to do the eras acquisition. Okay, and now look at that. The noise has gone down to 2 millivolts per division, or 2 millivolts. And so we have an even cleaner signal now than we do for the Tektronix. This technique is a technique where we can basically get 3 more effective bits of resolution, because this is only an 8-bit scope where the Tektronix is a 9-bit scope. And using this mathematical process here, we can effectively get 3 more bits of resolution and clean up the noise even further. And right now we're getting performance better than the Tektronix, but this comes at a cost. This reduces your bandwidth. But we're probably going to be doing a lot of that anyway, so this will come in handy. But anyway, there was something else that happened when I purchased this scope. I only purchased the MSO option right here. Okay, because all these other options here, these were like $200 or $300 a piece for these extra options here. Okay, I didn't even purchase the frequency generator because the frequency generator is not built in. Okay, you have to buy a separate dongle that goes into one of the USB ports to get a frequency source, a function generator, and you have to pay like $200 or $300 for the license. So in order to use a frequency generator, you're going to be out about $500. Okay, whereas you can purchase a separate frequency generator from Siglent for about $800. That's 122 megahertz. So it doesn't pay to only get a 25 megahertz function generator to pay $500 or $600 for it. But when I got this, I only purchased this feature. When I got it, they had enabled all of them for me except for the bandwidth option, which is okay. But it was nice. They turned everything on for me, and I double-checked all these things are on. Okay, I don't know if you can read them in there. So I got the function generator option turned on. We may even buy the dongle for that. Okay, so that was a nice benefit. They turned it all on for me. Okay, and that's because the only thing I was definitely going to use was the MSO option on this. Okay, so that's where this is right now. So the only other complaint I have about the Siglent, and this is really a childish complaint, is their buttons down here. Why didn't they put a tricolor LED that matched the trace? These all come up green. I mean, they did it up here for the run stop button. I mean, that changes color to run to stop. So that's just a minor nit. And the only other minor nit is the probes. Could have been better shielded, but there are other probe makers out there, so I'm going to explore that option next. Yeah, this is it for now. So the Siglent is working as good as the Tektronix is. It's definitely going to become the flagship scope. Again, this is the SDS5034X. This is not the same scope you saw in the last one. The last one was the SDS2024X, which is a lower frequency scope. But that scope had the nice 8x8 input grid. This guy doesn't have the option for the 8x14 input grid. This only has the standard 8x10. I really like the 8x14. That was another little nit. I wish I could get that on this scope because I really like that wider input. And so it's working. It's working acceptably. It's working as a good replacement for the Tektronix. And let's leave it at that. And I want to thank my Patreon folks for their support. Anyway, that's all for now.